Hello, everybody. Are we here? I think so. Just check my sound. Yep. All right. I think we're good. Okay. Am I streaming on all the streams? I think so. Let me get on my chat here. All right. We are ready to go. Hello, everybody. Welcome to the Future in Space Hangout at deepastronomy.com. My name is Tony Darnell, and today we're going to be talking about the James Webb Space Telescope. In other words, and specifically, I'm going to ask the question, is it too big to fail? Now, this isn't just clickbait. I don't post clickbait because I hate algorithms as much as the next guy. And even though the two of us, you and me, are sitting here giving away valuable personal data to social media platforms so that they can sell us stuff that we can't get because the supply pipelines are all broken down right now, I'm not here to pander to that. So what I'm going to do is when I post a question, I lost my train of thought. You could tell I did because I was looking at the chat. So whenever I post a question about these streams, about these discussions, I plan to have an answer. This isn't just clickbait. Okay, I am going to answer the question is with a yes or no, and I'm going to give you reasons for why I think it is or isn't too big to fail. As we go along here. So stick with us. I've got, as I always do, I put together some slides to keep my mind going in a path that's halfway coherent, and I'm going to bring those up here in just a minute. But let me say that I am streaming on all the streams: YouTube, Twitter, Twitch, and Facebook. And I'm looking at all of your chats now. I see them coming in right now. So welcome everybody. It's good to have you there. People on Twitch all saying all saying different things. I love this one. I hate algorithms. Is that you hate reality then? Yes, that's right, because that is our reality these days, isn't it? Algorithms. You will never hear me ask you to subscribe or click a button to ring a bell, or I don't even care if you like or dislike these things, because I don't want to play that game. In fact, I'm trying to build an actual community, which I have a long rant on that, but I won't get into it right now because it's not pertinent or germane to our discussion today. But one day I'm going to get into this cult/personality thing that everybody has to develop on various social media channels. I'm not after that. I want to have a discussion. With that in mind, the best way for you to do it is to, well, you're already doing it one of the easiest ways. It's kind of lame, but we have all these chat bots on all the different platforms that you can chat with. I've got them all. Queued up here, and I'm looking at all the different ones, and you guys are chatting quite well on these. But there's a better way. I have a Discord server. The link to that Discord server is in the description box. If you go to that Deep Astronomy server and you click into the live stream channel, voice channel, you'll be in there. And as soon as I put my headphones on, which I'm not right now because I don't want to get distracted, you'll be able to talk to me directly. And then I can push a button on my little mixer here, and you can go and we can discuss things live on the stream as if this were a call-in show. I would like for you guys to have the guts to do that. Get over there, do that. Every once in a while, somebody will get on there and talk to me, and that's always a lot of fun. So we can interact. This is actually a discussion in the stream. The format is something like this. I ask a question or I pick a topic that interests me. I'll write up a few slides to kind of get the conversation going, and I'll talk about them. And then after that, I'm done with my slides. We'll start discussing things. So as I said, today we're going to be discussing JWST. Oh, and I also promised Dr. Brian Keating, a friend of mine who I've streamed with many times in the past, just came out with a new book on thinking like a Nobel Prize winner, where he's interviewed a whole bunch of Nobel Prize winners. He has a great channel, so if you don't know about him, you should. And the link and all that stuff to his stuff is down in the description box as well. So congratulations, Brian, on your new book. And we should have a stream sometime again, now that I'm streaming again. I wasn't for a long time. Okay, so let me bring this up here. There we go. My little slides, my little slideshow. For those of you who do have the guts to join in on the live stream voice channel, I'm not going to put my headphones on until this is over, nor will I look at the live chat as it scrolls by while I go through this, because I don't want my train of thought to get. I'm an old guy, and my attention span is about that of a gnat these days. So I want to be able to get through what I wanted to get through. So I made these slides. The James Webb Space Telescope, which, by the way, news is out on it today. Let me just get to that real quick. NASA decided today that just today that they're not going to rename it. The James Webb Space Telescope will stay the James Webb Space Telescope. Now, if you're asking yourself, well, why do we care? Well, the answer is they were thinking of renaming it because it was a signature petition of about 1,200 signatures of astronomers and the general public and academics of all kinds who objected to the name James Webb Space Telescope because apparently it is alleged that he was a bit of a tool back in the 60s when it came to homosexuality and LGBTQ stuff. So they wanted to get his name off of there. And Eric Smith, the project manager, today announced on NASA that NASA is not going to rename it. They looked into it and they said that they didn't see any evidence that warranted a renaming of the project. Case closed. They didn't say anything more than that, which is a little disappointing because, well, why did they arrive at that conclusion, and on and on and on. But they did this. There was a chance that they were going to rename it because, of the allegations against him when he was administrator at NASA. I always thought it was a dumb name I call it JWST anyway. So also today, NASA confirmed that the JWST is actually en route to French Guiana now. They wouldn't confirm nor deny it in recent interviews, but Jeff Faust from spacenews.com, a really good source if you care about latest news, he said that they have confirmed that the JWST is on its way to the launch pad. So there you go. It's on its way. Now let's get started. Okay. Now, as I was thinking about the best way to talk about this, I was like, well, what's the best way to get the context of what we mean by too big to fail? And I thought the best way to talk about this would be to give it a little bit of history to what we have been through, what the project has gone through, and to sort of just put it all together in one place so that we can talk about this at the end of it. So, believe it or not, work began on this telescope way back in 1989. This was before Hubble was launched. Hubble was launched in 1990. Okay, and it was discussed and conceptualized from between 89 to 94, and they were thinking they would like a high Z telescope. These are things that look way back into the early universe, of redshifts very, very high, right? It was good. They thought, well, they might have a 4-meter objective, and they thought initially that it would sit about 3 AU away to produce noise from zodiacal dust. And zodiacal dust is just a fancy word for all the debris left over from the formation of the solar system. So it became the next generation space telescope in 1996, and then it was named after James Webb in 2002. And I just told you they're going to keep it that way. So it's always going to be James Webb. So when it was NGST, though, this was in the mid 90s. Everybody was like, just go, build it fast and let's build it really good and cheap. That's the way NASA tried to do everything back then. And it was initially going to have an 8-meter objective. And then they decided instead of going 3 AU away, they would put it at the L2 point. It was going to cost about $500 million. And then in 1999, NASA picked Ball Aerospace and Lockheed Martin to do some concept studies. Can we build this thing? And then, if we could, they were going to launch it. Some of this is funny, but it's true. Launch it in 2007. Okay, so in 2003, NASA awards $840 million to TRW, which is a company that was later bought by Northrop Grumman in a hostile takeover. And during this time, after the concept studies done by Ball and Lockheed Martin, the mirror was de-scoped down to 6.5 meters. Launch date was going to be 2010. NASA Goddard was going to manage the thing. they announced that John Mather, the guy who worked on these Type 1A supernovae Nobel Prize, would be the project scientist, and that Ball Aerospace would build the optical tube assembly. In 2005, cost overruns already happening, and in August of that year, they did a replanning of the whole mission, and they found that they needed to make significant changes to the integration and testing, which pushes the launch back 22 more months. It was already late now to from 2011 all the way out to 2013, and they said they descoped it again, and all wavelengths less than 1.7 microns were cut out. So this is strictly an infrared telescope at this point. So after the replan, the cost is now $4.5 billion, right? We ballooned here in quite a bit in a short period of time. They're going to put $1 billion in operations and $3.5 billion for all the other stuff. And then ESA during this year says, hey, you know what? We'll contribute 300 million euro and we'll give you the launch. So 2007, this was the time, because 2007 comes around. This was when we were supposed to launch the first time around. Construction starts. 9 out of 10 technology items passed review. This was a big deal because remember, a lot of stuff had to be invented just to be able to do the science. And they did a review, which represented the beginning of the process that sends everything into a detailed design phase. That this also in 2007, the Canadians pledged $39 million, to build the fine guidance systems and the near infrared imaging and slitless spectrograph equipment on JWST. At this point, costs are still on target. This is the $4.5 billion target. So let's go to 2010. Finally, we passed the mission critical design review. This is where everything was finally settled and said JWST can actually do what it was built to do. But they also did another review and they found more problems, which led to another replan. Now we're launching in 2015. Cost overruns are happening again, and it's starting to impact other NASA projects, other things that NASA's trying to do in the science directorate. It doesn't affect human space, but it affects things going on in the NASA science directorate part, and astronomers are starting to get a little bit pissed off. I remember going to meetings back during this time frame, and when you find out you work at the Space Telescope Science Institute, and they know you're going to be doing JWST, there's always this look on our face about, well, I hope you guys are happy because we're not getting anything else built because of this. And it was true. NASA had cut out a lot of stuff, except for the mid-range stuff, things like OSIRIS-REx. Of course, New Horizons was already going on, other things, but this was starting to impact other stuff. So after finally passing these reviews, now we start hearing from NASA about how so much about this mission has never been done before. And so space is hard, right? That we hear that all the time. So 2015, 2016, not a whole lot happens. They install the mirror segments. Construction is finished by 2016, and then integration and testing begins. This is the part which got interesting. So in March of 2018, Northrop Grumman tears the sun shield during a test, and the sun shield cables don't tighten. All kinds. It's just a cluster, you know what? Which means that NASA has to delay the launch until May of 2020 or later. There is another review of this independent management or independent review board takes a look at things and goes, all right, there's a lot of problems here, especially with management. NASA was being very optimistic about its own opinions about what it can do. Northrop Grumman, which isn't used to building stuff like this, it's used to building $39 billion fighter jets. So, it doesn't pay attention to small, billion-dollar expenses like this. So it didn't care. It was like, what's a big deal? We'll just keep going. So the Government Accounting Office really handed NASA their asses on this and said, there's a lot of problems here. And you've got 344 potential single points of failure. This is a single point of failure is just one thing that could go wrong to ruin the whole mission, right? And there's 344 of these in the James Webb Space Telescope program. Cost goes up to 8.8 billion. I remember doing Space Fan Newses on this, and that actually exceeded the cost cap that Congress said you could spend on this program, and it almost gets canceled. Congress is really thinking hard about whether or not it wants to keep this thing going, but it does. It gives it another $800 million, and now we're getting up to around 10 billion or so dollars for this whole thing in 2019. The pandemic hits, which delays things a little bit more. But in 2021, this year, NASA announces that JWST testing is complete. The telescope is now done here in 2021. Remember, 2007 was when it was going to get launched initially. Then it was 2011. And so I'm doing this so that we can kind of get a good feel for what we've been through. So finally, packs everything up, and of course, NASA confirmed today, as I just told you, that JWST is in fact on its way. It's not sitting around in its container, it's on its way. And so launch prep will begin for a December 18th, 2021 launch. And Thomas Zurbuchen, who runs the science directorate at NASA, goes on record as saying, you know what, it's okay to be terrified. Everybody is now starting to feel the impact of this whole thing. So we've got a lot of risks here, right? There's the launch, which is obvious, right? Anytime you launch anything on a rocket, if the rocket blows up, the mission's done, right? But then there's commissioning. And this commissioning has, like I said, 55 different points of, well, I haven't said that yet, but it's got about 55 or so different commissioning targets that it has to meet. And so that's also a huge risk. This thing is not serviceable. So once it leaves the ground, it's on its own. Okay, and there is no way, I don't care how much you wish, because of the way it was designed, JWST will not last as long as Hubble. We've talked about this many times. I'm going to have a countdown to JWST episode on this in about a week, and we'll talk about this more. But there's just no way JWST can be serviced. So what it has, and that's what it's always going to have. And if this thing fails in any step along the way, Thomas Zurbuchen has said that this will put U.S. space astronomy back 20 years, 2 decades, if this fails. That's how catastrophic this is going to be. So let's look at some of these single points of failure, right? Usually it's the launch that is the biggest one. Certainly that's true with Mars, right? Mars had about 3 times, a factor of 3 less single points of failure than JWST does, right? So it's unique in that almost all of the risks occur after launch. If we get the launch through okay, that's just the start of our problems, because we have to go through these other 344 single points of failure. There are 50 individual deployments. This is after it launches and the fairings have gone away and it has left the rocket. We've got to deploy 50 different things on the way. And if for whatever reason this thing doesn't launch right, this thing doesn't deploy right, or this thing does not get inserted into the L2 orbit it needs to get into, it's a complete failure. Because everything has to work this particular way. It has to get to the L2 point, and because if it doesn't, it won't get the science. It won't get cooled. It won't be able to look at the things it needs to look at. And Thomas Zurbuchen has said, quote, "Those not worried or even terrified about this are not understanding what we're trying to do." This is the guy running the mission directorate, okay? So he gets it. Everybody gets it that works on this thing. They know this thing is a huge cluster, you know what. So is it too big to fail? Here's your answer. Yes, it is too big to fail. The consequences of this are extremely high, not just for NASA, but for the entire astronomical community that has put a lot of eggs in the basket. In the same way that if our banking system had failed in 2008, we'd be in a world of crap. It's true here with space astronomy and JWST. It is too big to fail. The effects on space astronomy not just in the United States, but across the world, will be immense and huge. So it must succeed. The scientific discoveries that were meant to be made with this design will have to wait decades longer because nothing else is coming along that can look at what JWST will look at. W1st can't. That's the next thing we're going to launch, which was also announced today by NASA that W1st is delayed from, I think, from 2026 to 2028, I believe. So that's being delayed as well. So nothing else. There's nothing that can look at it. Now, I don't want to get too much into, before I do that. So while it is too big to fail, and the consequences are astronomically huge if it does fail, we need to remember some things. Yes, NASA and Northrop Grumman have screwed this up along the way. This was a big deal. This was a hard thing to build. And Northrop Grumman, it's just, like I said, it's a defense contractor. It spends $1 billion on toilets. It's like, why are you so upset at an $8 billion spacecraft? This is nothing, right? They don't get it. They've never worked on a civilian space project like this before. They're used to just having these open-ended whatever fighter programs that keep them going for forever. You know, money is just infinite to them. So they're having a hard time understanding what the big deal is, but NASA knows. NASA doesn't have a lot of money like that. NASA's not military, and yet they still had some pretty arrogant moments throughout the decades that led up to some of the problems we've had here. And we paid the price both in cost overruns and schedule delays all over the place. But let's remember something. Nothing this large has ever been launched from a rocket. This will be humanity's biggest deal into space at one time. So, and also nothing in space has looked at all the wavelengths and at this resolution that the James Webb Space Telescope can do. This is without a doubt a ballsy move by NASA to build this thing. This is a ballsy telescope. Okay. And in fact, I wish we could hang a little pair of those, those balls you always see at the back of pickup trucks. The JWST needs one of these. This was gutsy. This was a gutsy move. We've never deployed anything like this that had a sun shield. This sun shield is completely new. Nobody's ever deployed anything like this. 5 of them, actually. So, and finally, there's nothing that exists now, nor in the foreseeable future, that's going to show us the universe like JWST will. Let's remember these things. Here's a couple of graphics real quick. So what are we getting for our money? Well, you can see up here, there is all of this ground-based. This is how far back in time, and this is what we mean by high Z. Z is down here at the bottom, so a high Z telescope would be somewhere around Z equals 10 and up to Z equals 20, according to this little graphic here. This is the high Z telescope that was initially conceived back in the 80s and early 90s. The Hubble Deep Field, the one that was took in 95 that I made the video about all those years ago, was looking up at about Z equals 4. Later, with better equipment, after they updated the cameras, it was able to see out to Z10 or Z equals 7, about 800 million years after the Big Bang. And then finally in 2010, they did the ultra deep field in IR, which they were able to go all the way back to Z equals 10, 480 million years. So this is where we are, and this is where JWST is going to go out to about greater than Z20, Z equals 20. We're talking just a few 100 million years after the Big Bang. Okay, and this is an important time because it's called cosmic reionization. This is a graph of what this is. Didn't quite turn out the way I had hoped, but we'll but you can see here that this is the universe, the JWST at the top, going all the way back to this area called the Dark Ages. This was this period between where the Big Bang cosmic microwave background front is, and in the beginning of the era of reionization. This dark age period was a period in the universe where the universe was opaque. Any photon that traveled any distance didn't get very far before it hit something else and was absorbed. So That's called the Dark Ages. Light did not get out. It wasn't until the universe expanded a little bit more that the radiation that was trapped was able to be released and reionize other atoms to create the universe, the beginning of the universe that stars, galaxies, things like that. No one really knows what caused what's going on in the era of reionization, but JWST is going to look directly there. It's going to show us that. We're also going to be able to look at the very first stars, the very first galaxies. Nothing else can do that. And then we're not talking about among the first. We're talking the first stars and galaxies. So that's what we're getting for our money. Finally, and I'll just point this out briefly, and that has to do with the exoplanet work that it's going to be doing. There are, in addition to the Canadian near-infrared imager and the spectrometer, there's also NIRSPEC, which will look at atmospheres of distant exoplanets to see what's in them. And it'll also have NIRCam, which is an infrared camera. So we're getting a lot of stuff. Are we getting the best bang for our buck? Probably not. This is a government military contract run thing, so we never get our money's worth off of these things if you look at it from a value perspective. But I don't know, how do you place a value on discoveries like this? So JWST could fail. It's still, I mean, they've managed the risks as best they could, but we've got a lot of things ahead of us here to see this thing go through. So it is going to be catastrophic, not just to NASA, because half of NASA is the science directorate. The other half is the human space part of it. That's the part that runs the astronauts, the Artemis program, the ISS, all that stuff, right? Which I think now they've split up into two pieces as well. There's the part that's like routine operations, like the ISS, and then there's things like Artemis, which is a development kind of program. So NASA is now in three main parts. But half of it is the science directorate. That's the part that does JWST, Chandra. It's the part that does all of the Mars rovers, the stuff that's the Dragonfly going to Titan. All of that stuff is done in the science directorate part of it. New Horizons to Pluto, things like that. And it's going to kill. It's going to hurt NASA to the point where, I've heard people worrying about the future of NASA if this thing fails. That's the stakes. Okay, so this is very much the scientific analogy to the 2008 financial crash if it goes down. So, so there we go. That's my little spiel. And now I'm going to look at some of the chats here. Let me also put on my headphones. I don't know if anybody is in there, but let me hit escape. Oh, somebody is here. Okay. Let me hang on just a sec. I'm not. Oh, this is Tony. Okay, hang on. Let me put you on the stream. Okay, go ahead. Okay.
Okay. JWST is much like the Apollo thing. Why do we do it? Because we can, right? And
well, that's not fair.
I know
why we did Apollo.
I know.
Okay, go ahead. I'll let you finish.
Yeah. So the thing is that you pour resources into where you think you want to put them. I mean, and this is research, right? This is research, and you don't know the benefits that you're going to get or the spin-offs that you're going to get. So the thing that concerns me is most about JWST is there is no backup here.
No.
And Murphy's Law says that something is going to go wrong. And I'm reminded of what Elon Musk does, which is itinerative. And he records, these little cameras on his spacecraft to see what goes wrong. And I don't know if JWST has this provision. If this blows up on launch, well, that's pretty standard stuff. But I mean, this is one chance to deploy, and you can pretty well count on Murphy's Law. So is there anything in place to learn from what goes wrong? Or, you know, or just the cinematography of these things deploying, right?
Yeah,
At the
well, I
very
don't know
least.
how you'd do that. I mean, what would you suggest that we maybe put a bunch of Pathfinder missions that come first? I mean, for example, what a lot of people do in this situation is they want to. The European Space Agency wants to build LISA, which is the next generation of gravitational wave detectors in space. And before they build this thing, they want to make sure that it's going to work. So they launch these things called Pathfinders. And there was a LISA Pathfinder mission that launched in 2016, I believe, that went to make sure that they could, in fact, build these detectors that worked. And they did. And so, but if we did that, then, if we did that for every little thing that we were going to launch, then it would take even longer than it did. So there would be a pathfinder, for example, for the sun shield deployment, right? You would want to make sure you could
Hmm.
deploy this thing in space. There'd be a pathfinder for the various detectors that are out there, or the cooling mechanisms, or what's it like to sit out at L2 with this big giant thing hanging out, everywhere. Uh, you could do that, yeah, but that would cost a lot. And NASA has always had to work on a very constrained budget. And so I don't know how you would do it other than that. And they obviously couldn't. This is a hell of a risk.
Yeah.
I mean, you're right. This is all one gigantic risk. One that I think it outstrips anything they've ever done. Human lives are not on the line. So in that sense, it's not as
Um,
risky, but existentially it could be, I think.
yeah. Well, the thing is that don't they have something you know,
No, to answer your question, no.
I know they're going to have some telemetry coming back, and maybe a video feed on just so that if it does go wrong, we could learn something. You know, I don't know what they're doing. I understand that they're going to try to do it all at once, and that's what we're doing.
Right.
But I mean, the chances are that Murphy's law goes into effect, and if we can't learn from that, right, that what went wrong,
Well,
then
I think we will.
yeah.
There'll be lots of opportunities for learning from the failure of this. There's going to be a lot of detailed telemetry coming back. So God forbid it does, something go wrong, they're going to know. I think they're going to have it down. I think to where they could at least learn from that mistake. It'll be the most expensive mistake they've ever made, but there'll be ways to learn from it. It's more about
Yeah.
risk management at this point, and I don't know how any of you project managers out there would know how to do this, but there's a way, I guess, that you mitigate your risks, that you identify your risks, and that you make sure that you've mitigated them within your project somehow. And then
Well,
there's all these things, and NASA has gone through several of these where their risks have been identified and then supposedly dealt with to a level that makes them confident for launch. So that's all I can say about that.
Well, that's all project management, right? That's
Yeah.
the deal where you say, what's the worst thing that could happen? And I do that in everyday life, right? What's
Mhm.
the worst thing that could happen if I get in my car and I drive down the street while I get into an accident,
Right, but there's a more
right? I got
formalized.
airbags, I got all the rest of that, right?
Right.
And it's, well, if you live that way, right? And I think that Chris Hadfield was one of the guys that says, yeah, that's how astronauts deal with this, right?
Mhm.
What's the worst thing that can happen? And how do we mitigate that,
Yeah.
right?
Yeah.
And I think that they've done that with JWST. But I I'm just saying that this is research. I mean, you don't know what the benefits are going to be until you have, and it's not just that we're going back to see the early universe. There are other things that we are going to discover because of this, right?
Oh,
That we
absolutely.
don't know right now.
Absolutely. I mean, by comparison, Hubble's mission for being, which was to measure the Hubble constant, they did that within the first year or so, and then we went on to find out all these other things that Hubble discovered as a result of it. But so yes, you're right about that. The discoveries are just completely unknowable at this point. We're gonna see things that are astonishing without a doubt. Let me get to
Yeah.
Fawad's comment here, Tony. But the issue is, will NASA have money to learn from the mistakes and rebuild? such a huge telescope ever again? I don't know. It's like, that's a great question, Fawad. I don't know. I think that this could be existential for NASA if it doesn't. If that's what I mean about too big to fail, right? If it fails, this could mean it's certain. I mean, you could everything will come to a screeching halt. Everything about NASA will become very highly scrutinized by Congress, especially in the science directorate. And of course, there's things like Artemis, which may never get off the ground at this point. So the answer is I don't know. Rebuilding, it depends a lot on the makeup of Congress at the time. Congress really drives NASA quite a bit. So it just depends. And of course, we will have a say in that as a general public as well. But um, okay, so Steve Craw, is that right? Yes, but Murphy's law does not account for probability. So what are the probabilities? I don't know. All I know is they've got these metrics within which they must be before they are launch ready, and the testing and integration period was the part that set those ranges, those metrics, and so it would not have gone, I think, um, uh, otherwise, if they hadn't made those metrics. So that's all I can say. Nick Hardy is commenting, maybe it would be better to launch multiple smaller telescopes and use them in unison. Uh, that might have, yeah, it's too late for that. But the concept was done. This was set pretty much in the early mid 1990s when Ball and TRW, no, Lockheed Martin did the concept reviews. So I'm going back up. I'm now scrolling back up through the chat, guys. Let me go all the way to the beginning. That way I'm not just going in reverse order, so I can make sure people who did something first. See. Let's see. Stay is commenting. It's not too big to fail. Already, NASA already has W first in the Space Telescope pipeline, and it will not be the last. Don't be so sure, man. Do not be so sure about that. That's all. Eric's commenting. Let's all hope it doesn't explode. Absolutely, no exploding. Yeah, there was a period where they were going to cancel it, and it's not unheard of. We've canceled projects in the past in this country after spending billions of dollars on it. So it happens. Eduardo, honestly, I think that all these politically correct trends are harmful. Nothing is perfect, and we can and should improve, but we shouldn't trash civilization because of this. I'm not quite sure what. Maybe you're referring to the James Webb thing. I don't think that's trashing civilization, but anyway, maybe you're talking about the homophobia thing. Why build one when you can buy two for twice the price? That's from Eric. Yeah. Let's see. Tony's Twitch Thursday. That's right. Tony's Twitch Thursday. That's on Twitch. Let's see. I still think it should be renamed because it is the biggest, the best, and most innovative. It should be called the Titanic 2. It will not fail on the maiden voyage. Freedom says it's launching on its birthday. So that's great, man. I hope you have a good day. But Alan is saying that's going to be one stressful day. Yes, it is. Remember, it's going to be the deployment, the commissioning, which includes the deployment and first light and getting to L2. We're looking at weeks, several weeks. That's going to all happen. So it'll be a crazy time. Let's see. They will have turned that rocket inside out a dozen times, checking every part and bolt. Well, they did that with the spacecraft already. Hopefully, ESA has got this down with Ariane 5. There was a bit of an issue with Ariane 5, but they seem to have worked that out with this unexpected acceleration from the payload. But they've added vents to the fairing, and now that should be set. Yeah, I know. I put this together real quick. This is I can't read some of the text. I know. I got this busy image in the background, and I'm using Google Slides, and so I'd only have so much ability to make things, go down there. And so, sorry about that. I know it was a little hard to read. It was just mostly for me to keep my thoughts straight. Hey James, it's good to see you. Jimmy D from Australia. So way to go. Welcome. Fawad is commenting again. Looking at Hubble's history, I fear that it'll have mirror issues. I hope not, though. Yeah, I'm sure maybe you don't, but in 1990 when it launched, Hubble had problems, right? The contractor that built that, which was Perkin Elmer, built the primary mirror for Hubble, put in some lovely spherical aberration, and that's like telescope making 101 mistake, right? So it was really embarrassing for NASA. It took them years to get over that. And that's also in part why they've been so secretive about everything about JWST. They are very gun shy. And in this day of social media, they have to be even more careful about what they do and how they say things and everything else. So, yeah, man. I mean, I, with all these single points of failure, over 300 of them, one can easily imagine one of them occurring. And in which case, it's single point of failure. It means the whole mission doesn't work because that one thing didn't happen. This is all or nothing. Way more, I think, than Hubble, because remember, Hubble was designed to be serviced by the shuttle. They put it in low Earth, or I guess it's high Earth orbit. I don't know. The highest orbit that the space shuttle could go is where they put Hubble. And that, it's been repaired 5 times since it was launched. So it's got 30 years out of it. There's no way JWST is lasting that long, right? They've got it going for maybe 10 years. And of course, the limiting factor is going to be fuel. When it sits at the L2 point, it has to do corrections every few weeks to keep it in that orbit. Plus, it's got to be moved around and pointed. So when it runs out of fuel, that's it. The mission's over. So it will not last as long as Hubble did. Cannot repair this thing. So let's see. Good evening from England. Yes, good evening. Decades later, I keep thinking about the chip shortage, labor shortage. Yes, let's hope things go well. Right. And this is from Bullshit Vendor. When a contractor can sell a bolt to a government agency for $1,500 apiece, no wonder capitalism makes taxpayer billions disappear like a fart in space. Yes, it's sometimes Northrop Grumman, like I said, they spend money like that. They don't get it. It's like, well, I don't understand. This thing came out, it only costing $10 billion. Why are you so upset? Because they're used to 30, 40, $50 billion projects. Let's see. Joe C. Northrop Grumman is too busy building alien replicated vehicles, so they're not concerned about screw ups that they made on Webb. Right. John's got a good point. John Suffel. Money spent on JWST is not lost. It's given to workers as wages somewhere down the line. One can hope, or at least profits to shareholders of Northrop Grumman. I'm sure some of it goes there too, John. So let's not forget the shareholders. And of course, Eric points that out here. He says less wages and more returns to stockholders and CEO bonuses. Which dark ages are we talking about? We're talking about the universal dark ages, man. These are the big one. Not the dark ages that was in Europe, okay, but the dark ages of the universe. This was a period in time when the universe was small enough and the matter in it was so great that a photon that was emitted from one atom would be immediately scattered and hit and absorbed by another atom. And that they use the term opaque to describe a universe where light doesn't escape. As it got larger, those photons were able to escape, and that energy from those were able to reionize, in other words, strip hydrogen atoms from their electrons from their hydrogen atoms, and we had ionized, and we had ionizing radiation, things like that going on, and the first stars and galaxies began to coalesce at that time. Okay, so Richard Cole. Let's see. Nothing can see the first stars as inflation means they're traveling away faster than the speed of light. The first stars happened way after inflation. Okay, I don't have my little. Well, let me just. I don't know if I can put this up. Let me look. So here's my screen. This little sad little graphic here was not great, but inflation is back here. Okay, this is we're talking a period well after the universe cooled after the Big Bang. So a few 100 million years later. Okay, and inflation was not a part of this era. Reionization, when all the photons in the universe are knights and squires running around on horses. What? Indeed. Should be interesting with more info on Proxima b. Galaxy is commenting, maybe JWST is much too big to fail, that it is better to rebuild it when it fails because it is much cheaper to build a second time now that they know how to. Yeah, if they get that chance. Thomas Verbruggen himself said this will set them back 2 decades, right? So I'm hearing people join the, we got several people in here. If you guys want to say something, unmute your mics. You'll be live. Homo sapien and Nuki, I see you guys in there. So if you want to say something, just pipe in. Let's see. I'm just reading comments now. We're chatting. Compared to what they received in the 60s with the race to the moon, NASA is living on a shoestring these days. That's true. That's true. We spend billions on hammers. This is a drop in the bucket. Yeah, Eric is coming with, they already have plans for the next gen at JWST on steroids. You're talking about LUVOIR, I think. Yeah, that's right. And there's also the Carl Sagan Space Telescope, which is going to be it'll be a sort of a mid-range in between JWST and LUVOIR. So that might happen. Who knows? WJR Rasmussen from Twitch is commenting, JWST lets you take a deep field shot. Would you repeat a Hubble deep field to compare or a new one? Well, I think you could take the same one and see galaxies that Hubble could not see during that time. Remember, it can go back a little. Remember that graphic I showed you? It can go back a little bit further. So you might see a few more galaxies in the deep field than otherwise had been there. These deep fields are, days in the making, dozens of Hubble orbits. I don't know. I think JWST is going to be allocated time in units of orbits, but I think it might be L2 orbits instead. So I don't know if they're 90 minutes or not, but the Hubble is allocated several dozen orbits for these deep fields, and they take a long time to build up, but it would be cool to see somebody do that with JWST. So who should build the next if it fails? Well, it probably won't be NASA, and it might. If I had to go, I would say ESA could. Euclid's coming along. I think that's the next big thing ESA's got going. But I don't know much about ESA to know if they can have if they have this capability or not as far as their budgets. Architufus, they might not have, this is from Twitch, might not have a chance to do a Hubble Deep Field with JWST. It won't have a lot of downtime. I think there are about 25,000 targets already queued for it as of now. That's right. They've already allocated time. Astronomers have already been lining up for years to get time on this telescope, and it is fiercely competitive. That's not a bad idea, James. They should launch a few CubeSats to follow JWST just to see some video. Yeah, you want to be careful not to get in the way, not to mess it up. But yeah, that wouldn't be that's not a bad idea. Hi, Nick. It's good to see you. I'm glad you're here, even though you are late. I'll try to hold it against you. Good point. There should have been a pathfinder for deployment sunshade. Yes, well, again, that's time and money, right? And we could be sure about whether it would work or not. But could you imagine the delays that would have happened had a pathfinder been launched and got stuck? So, okay. Oh, he's correcting himself. Not 25,000. I forgot how many, but there's a lot. Okay, Arctufus. Let's just go ahead and say 25,000. That's all right. It's okay. I won't fact check you on that. Well, the chances are 95% that launch goes well. I think it's better than that. I don't think they'd do anything with as low as 95%. But again, I don't know how these risks are measured and decided upon. Nick is commenting, maybe better to launch multiple smaller and use them in unison. I think I'm getting caught up to what I already read. Yeah, I read some of these already. Okay, so I'm caught up. Okay, so Third Rock is commenting, did you hear about the meteor that exploded over the Shenandoah, West Virginia, roughly 60 miles east of Green Bank? I did hear about that, yes. And I don't think NASA knew about it, which is scary. We didn't know about it. It happened after it exploded. So that's the kind of thing we should know about. And that's also something we're going to be protected from with Vera Rubin telescope, right? Vera Rubin's going to be able to find stuff like this that's on its way and really close. Because right now, all we've got up there looking around in any meaningful way is Neowise. And of course, Vera Rubin's going to look at the entire sky every week, several times. John's commenting, if they do build a second JWST, it'll be cheaper from learning from the mistakes. That's right. I think I read that already. Third rock. Apparently, the meteor explosion was also caught on a NOAA satellite with the brightness of the moon and even registered on seismographs in the sonic boom. Yes. So let's see. Nick is giving it a 50-50 chance. Boy, that's rough, man. That's rough. Oh, I see. So all Ariane 5 rockets are 95% success. Right? I see what you're saying. Yes, we've got a lot of things out of the L2 point, Andres. Have we put humans? Have humans put something in orbit? Yes. So SOHO is at the L1 point, and there are other telescopes at the L2. It escapes me right now what else is out there. WFIRST is going out there as well. I'm sorry, I'm drawing a blank. There are other spacecraft at L2. It's a really cool space because it is a spot. The Earth Sun L2 is a point that a spacecraft can be in, and always have the Earth, the Moon, and the Sun on one side of the spacecraft, and on the other side of the spacecraft is deep space. That's one really good place. The reason why they're putting JWST there. It's also gravitationally unstable, meaning that things don't tend to go there like stray asteroids or stray meteors and meteorites, micrometeorites, things like that. It's a pretty clean spot because of the instability there. That's a plus and a minus. It's a plus for that reason because it keeps a lot of micrometeorites from coming by there, but it's a minus because every few weeks JWST has got to fire thrusters to keep it in orbit. It orbits around in a circle once it gets there, and that orbit needs to be constantly corrected throughout its mission, in addition to pointing at the different things it needs to look at. So that's a disadvantage of it. Let's see. More comments. But so guys in the voice channel, if you want to say something, go for it. JPix, some will not like it, but SpaceX may be the main, if not the only way to push through. Okay. There's more to life than SpaceX, but I get it. There's a lot of fans out there for SpaceX can do everything. Moon-based telescopes is the way to go. Steven, I'm going to talk about this in a couple weeks. I'm going to do another one of these streams, not next week, maybe the week after. I'm going to talk about lunar telescopes because we're going to go into that a little bit more. And Nick, we can talk about whatever issues you see in them as well. James Dugan is asking, did they fix the vents on the launch payload cowling of the rocket? Yes, I believe they did. They did fix it. They launched one rocket back in August. Arianespace had a different payload that it was launching. It's got another one before the launch to do as well. And I hadn't seen any news from it. I tried to find some comments about whether it worked or not, but there's 2 launches prior to JWST. One's already happened that would test this payload fairing thing. The issue was that there was when you went on an Ariane 5 rocket, when you had a payload loaded up and you opened the fairings to let the spacecraft out, there was an unwanted acceleration of the spacecraft payload that we don't want with JWST. You don't want anything unexpected. So, and the fix was to add fairings. They thought the problem might be a pressure differential, and so a pressure was staying in the payload area when it shouldn't be there. And so they added vents to the fairings. They did one launch already on this. Apparently it went well. They've got one more in the coming weeks before JWST launches. And I assume they consider the project or the problem fixed because I haven't heard anything about it. And I do believe NASA would say something, right? I mean, as averse as they are to saying bad things. They're going to tell you if something comes up, right? That's, I mean, NASA, say what you will about them, they have had to do everything in the public eye. This isn't like China or Russia where they can do things and nobody knows how it went or when it's going to happen or any of that. NASA does everything in full view of everybody all the time, and that has been a great thing. It's also been the source of a lot of tragedies and things that we would rather not have seen, but that's how NASA works. So I think that if this had been unresolved, the Ariane 5 rocket thing, that we would know about it by now. So we'd certainly know about it in another launch delay announcement. Right now, December 18th is still the time when it's going to launch. So good. All right. Someday it will be the best restaurant in a million miles. What, JWST will? Okay. All right. So stay craw. Even if NASA stops making space telescopes, ESA is still building space telescopes. So will ISRO, China, Roscosmos, and so on. Yes. You're talking about ISRO is India's space agency. China, of course, has got their big thing. They got all kinds of stuff going on, and so does Roscosmos as well. But I don't think the thing is, think about this for a minute. We started building JWST in the 90s. Actually, it started in 2007 was when it actually started getting built, right? So what are we, 24 or 5 years later? No, what, 15? What 2007, 2007 is 10. So about 15 or so years it took to build and test. 14 years. So you don't just do that, right? So if ESA wants to do it, if ISRO wants to do it, that's great. China wants to do it, awesome. It's going to take them some time though. So that's that. But there are other space agencies, is your point, and I see that. John is commenting, NASA rockets don't explode anymore. They suffer a rapid, unscheduled disassembly. That's right. I think that's a SpaceX jargon. The people who want to go to Mars can do a test run to L2 to fix it if it breaks. Matt Maniac says that. Yeah, it wouldn't be a bad idea, right? To have some space program go out there, manned flight, or even a robotic one to go out there and fix it. I predict this. Here's what I predict. Okay. If it goes out and makes it to the L2 point, but something doesn't deploy right, or something sticks, or doesn't open all the way, or I don't know, an amplifier goes down or something like that, when it finally does get to L2, causing the whole thing to not work, I believe NASA will build some kind of robot, or they will commission a robotic spacecraft to go out there and fix it. It's that big a deal. So I think they could justify that expense and do it. Now, it may be years down the road after it happens. And of course, at that time, it just depends on the nature of the failure, right? If the sun shield doesn't fully deploy, but it gets to L2, well, you just don't turn it on yet, right? And you wait till we can get something out there to unstick it. If it doesn't get to L2 and goes off in some random area, well, the mission's a failure. You can't fix that because they're not going to be able to go get it in time to bring it back or reinsert it into orbit. So the orbital insertion is vital. But there are some failures that we could have that would, while they would kill the mission temporarily, they could maybe hopefully be fixed. So I predict in those situations, NASA will build something and go out and fix it. Robotic, probably, because they've got this rover thing down. NASA knows how to make a rover, and they know how to do things robotically. Too much time to send people out there. We can't even get Orion working and the SLS going, and it's just way, getting humans back into space, low Earth orbit is something that SpaceX can do, but it can't get things 1.5 million miles away to the L2 point. As much as you love SpaceX, it ain't doing that yet. So I think they'll build some kind of robotic thing to repair it. I predict that. So ESA, yay. And Tariq is going, it's 1 a.m. here, 1:15 a.m. Well, welcome, and thank you for showing up. I'm glad you're here. Anthroparian is commenting, they should make it regassable by robotic spaceship. Shame to make such wonderful mirrors and treat them like paper plates at a party. Yes. I like that. Paper plates at a party. I'm going to use that in a script. Let's see. Yeah, James Dugan is just some guy in Australia who loves all this astronomy and space stuff. He's been around a long time. James is, I consider him a good friend, even though I've never met him. And it is very early for him. Well, yeah, I think it's early for you, if I'm not mistaken. Fawad, thanks for answering questions. No problem, man. That's why we're here. We're discussing, we're building a community as opposed to a cult, which is what most social media channels want you to build. They say, it's funny, they use these euphemisms. You should build your community. Your community of viewers would want to see this kind of content. They want you to build a community. What they really want you to do is they want you to make content, and then they want all these people to slavishly consume that content. And where one person, if one person stops making content, the community goes away. That's not a community, that's a cult. So what YouTube wants everybody to build is a cult. I want to build a community. It's harder. And that means if I'm not around, the community still exists, right? So that's what I'd like to build on social media. But that's what we're trying to do. This is a discussion. I want to get you guys as interactive as possible. Homo sapien, are you there in the thing? Just answer me if you are. You're in my voice channel. I want to hear your voice. Go on.
Yeah.
There you are. You're there. How you doing?
Doing fine, thanks.
Good. Put you on the spot, didn't I? Okay, I'll leave you alone. Nuki.
1:30 in the morning.
What?
Introverts of
1:30
the
in the
world
morning.
unite.
That's right. Introverts unite. Nuki, say something. Just say hi. I'll leave you alone. I'm not gonna put you on the spot.
Good evening, Tony.
Good evening. Welcome to the stream, and thanks for joining. I'm so glad you're here. All right.
I had a question on Facebook. I'm Dennis, by the way.
Oh, okay. I might have. Oh, I see. Oh, you're Dennis. I see your question.
Me.
Oh, Dennis Van Houwermeren. Is that right?
Van Houwermeren.
Van Houwermeren. Nah, thank you. Okay. I'm sorry I butchered it. Well, welcome, Dennis. It's good to hear your voice. I've seen your chat, your comments. In fact, I see it right
I'm
here.
the lonely Facebook man.
Yeah, I know. Yeah. Nobody sees me on Facebook because you got to pay on Facebook for anybody to see.
Yeah.
So I don't pay any money, so nobody sees me on Facebook. Even though I have thousands of followers on the Deep Astronomy Facebook page, it doesn't matter. So what's on your mind? You got anything you want to say? I mean, I got your comment.
Well, I was wondering who's the scientist that's going to have the privilege of being the first one to observe something.
Oh, do I know? You mean, is that your question?
Yeah.
No,
do you know who's going to be and what are they going to observe?
I don't know, but that's a good question. The time allocation committee is what decides this. And I'm just going to go look, and of course the Space Telescope Science Institute is running JWST. So let's see if we can find out JWST observing schedule. Let's see. I see the timeline. Cycle 1. Okay, so let me just pull this up. So the Space Telescope Science Institute runs the telescope, and they're calling cycle 1. That's the first. Every year, I think they run through all the proposals, and there's cycle 1. And so they've broken it down into 3 programs: small, medium, and large. The small programs have less than 25 hours. The medium programs are in between 25 and 75, and large programs are greater than 75 hours. The listing of co-PIs in the table below has been limited to 4. So they've got various categories here where they're looking at exoplanets and disks, galaxies, the intergalactic medium, large-scale structure of the universe, solar system astronomy, and all of these different areas. But let me expand one here. Okay, so they have an ID. Klaus, I know him. He's going to be looking at the deepest search for rare molecules and isoprologues in planet-forming disks. He's getting 13.4 hours to do that. He needs MIRI and MRS to do that with. There's a time series calibration of medium resolution spectroscopy with Drake Deming, and he's gotten He's got 12.8 hours. Then he needs to use MIRI and the MRS also. Search for our closest stellar neighbor and for planets in zodiacal emission. Charles Beichmann and Dmitry Mawet, they get 25 hours. And they need MIRI and the chronographs to do that. So it doesn't say who's going first, but if these numbers are any indication, like number ID is 1549, if they're sequential, then somebody must have number one. And I would have to click through all of this to find
Don't
it.
bother.
Yeah, can you see my disk? Can you see my desktop though? Yeah. So you see what I'm doing, right? I'm just clicking through this stuff, and there are lots of proposals. Supermassive black holes and active galactic nuclei. I'm not seeing anything below 1500 as far as a ID. So maybe they, who knows what it started as. But I don't know. I mean, so it's going to work a little bit like this. You're going to see the commissioning process, which includes unraveling and unfolding the whole thing. That'll take several weeks. Gets to L2, and then there's going to be a lot of things about turning on the instruments, getting it down to temperature. That's going to take some weeks, and actually that starts immediately after the sun shield is deployed, and then they start getting down to temperature, and then it gets to the L2 point, and then they got to do first light. So there's some commissioning images that have to be taken. Those will be the first, and you can be sure that when NASA gets a first light of anything worth looking at, then it's going to be published everywhere, right? So you'll see that. That'll be the first stages. And then this observing program will come in. Now, the way it worked with Hubble was that you were given time, so many orbits, I guess here that's hours. They're giving you hours of observing time. And you got to keep that data for a year where nobody could see it. So you could write your paper. That's pretty common. And then after that, it becomes available to everybody. It got put on the Space Telescope archive that's at the Institute, and anybody could go and download that data and do research on it. But it was embargoed for a year because the thinking goes that, you've put the proposal through and you need to write your paper, and it prevents a lot of people from trying to step on your publication, I guess. With Hubble, nobody actually paid for the time. The time was free, if I'm not mistaken. So an observer, unlike going to a ground observatory, an observer didn't have to pay. But they did have to scientifically justify their observing time. I have to look that up. I'm pretty sure I'm right on that. But I might have that wrong. Anyway, it's an interesting question. I mean, there's a lot of cool stuff coming on here. I mean, you've got large-scale structure of the universe, that'd be of interest to me, and supermassive black holes and all that kind of stuff. So, I don't know. We'll see. So that was a good question, though. Thanks, Dennis. I appreciate it.
Yeah, no problem.
Yeah. So, So, anything else?
No.
Oh, okay. All right. Well, thanks for joining in, man. I know it, but now see, it's over, right? And so you found out it's not that big a deal. So, let's do this some more. It's much better than me trying to search through all the chats here. Hans
What
Milling.
was the link?
What?
What was the link?
The link to what?
I'm sorry, to that web page
Oh, it's the Institute's webpage
that you were at.
Oh, all I did. Okay, so here I'll post it in Discord. Control C. Can I do that in this room, or do I have to? Okay, so I have the live stream chat. I have the live stream chat. So there's this. I put it in the live stream chat channel, and I will post it also on. I mean, all I did, can't post messages to some channels. Okay, maybe it's Twitter or something. I'm not sure. Anyway,
Yeah, I got it. It's open.
Okay. Yeah. So all I did was
Appreciate that.
Yeah. So but look what I did. So all I did was I went back here to Google, and I typed in JWST observing schedule, and it was down here.
Okay.
Cycle 1.
Let me Google that for you.
Yeah. So that's all I did. So you can find it yourself. So cycle 1, it's going to be a big deal. Hans Milling, it's good welcome on Twitch. No matter if you give it 59 or 0.1%, if it fails, you will just say it within that percent. If it's exceeded, you'll say the same. Yes. I think stereo is actually two telescopes. One, are they? I don't think they're at Lagrange points. One follows ahead of the sun. One follows the sun, and one is ahead of the sun. They're called ahead and behind. And I don't think they're at L2 points, but they do follow the sun in an orbit around the sun. They go in an orbit around the sun, so they follow a distance. Maybe they are at an L2 point. I have to look it up now, but yeah, you may be right about that.
That sounds like L4 and L5.
It could be.
Those are sun observatories. What's the name of it that you're
stereo? It's they're two solar observatories.
Oh geez, I'd bet money on it. I would have to look it up.
It may
but
be.
That's
It's not
what
L2,
I remember.
but it may be another Lagrange point. I don't know. I guess in order to be able to
L4 and L5.
Are they?
Okay. I believe.
Yeah. All right. Cool.
Yeah.
Okay. Is there any way to robotically fuel JWST? No jamming, not yet. There is no way to do anything to get there. John's commenting, space, the final frontier. These are the adventures of James Webb. Oh, crap. It's crashed into the Pacific. Let's hope you're wrong. Planck was at L2. Okay, I knew something else was out there, Nick. I just couldn't remember what it was. Jammin, sorry. Which target for JWST are you most excited about? I think the exoplanet targets. I want to. Right now, all we know about exoplanets are their size and their masses and how many there are around stars. That's all we know. And so I'm most excited about the near spec and the near infrared slitless spectrograph that the Canadians built to teach us more about the atmosphere composition of these exoplanets. That's one thing. Also, the very first stars are going to be these bizarre looking stars that I would love to be able to learn more about, as well as the first galaxies that ever coalesced from those stars. So this is a strange time in the universe's history, and so I'm very excited about those two main aspects of it. So let's see. The Droplet, just wait space telescope. This thing is not launched due to technical issues, but it's a very good money milking machine. It has been so far, although I'm Northrop Grumman. I like to them this isn't the noise. I'll be sad for a long time too, Alpha Destrius. I will be too. What is ESA's next space telescope? I think it's Euclid, if I'm not mistaken. Somebody correct me if I'm wrong. I was on a 486 when JWST was announced. Now, it probably has a 486 on board. Anthroparian, science will go on. Science will find new ways to push the knowledge. Remember, there are lots of telescopes coming online soon. None of them, you're right, but none of them can do what JWST can do. That capability is it. Okay, so this wavelength range and the resolution that we're talking about, 6.5 meter telescope in space doesn't come along every day. And you're not going to get that just by any other things. WFIRST is same size as Hubble. So 2.4 meters, tiny little thing compared to JWST. So there aren't any in the wavelength range nor the objective size coming along anytime soon. However, your point is well taken. You've got WFIRST coming up next. Euclid is also coming up from ESA, and of course, I think the space. Chinese are doing something, I think, with the space telescope, but I don't know for sure. And and of course, the ground-based telescopes like Vera Rubin and the Square Kilometer Array much down the line, those will also be coming online, but they will not look in the infrared regions because you can't from the ground that the JWST will be looking at. So why not a manned spacecraft? Do you honestly think, Hans, that they're going to be able to get their stuff together enough to launch people to the L2 point? I just don't think they're going to be able to do it. Getting to the moon in 2028 is going to be a big enough deal. But to this kind of thing, you know, talk about building from experience. We've been to the moon, so we've got some experience doing that. We've never been to the L2 point to repair something. So that's experience we don't have. And I don't know. Maybe everybody seems to think Elon Musk can walk on water. So maybe he can make something happen in, you know, a couple of weeks, and up they'll go. And Bruce Willis will come out of his Dragon capsule and fix the JWST, and it'll all be a big made for Netflix event, and it'll be fixed. Who knows? I mean, there's plenty of people who have a lot of hope that they put a lot of faith in Elon Musk's abilities to do just about anything. So will you join my cult? Don't join my cult, man. Join my community. I don't want a cult. Cults are a lot of work. Why do people want to be in a cult? And why, even worse, do people want to lead a cult? That's a lot of work. It's a lot of responsibility too. So I'm glad you joined my cult, Matt, but I don't want to have one. Hey, Con Greg, it's good to see you.
Okay, I was wrong.
About what?
It's about stereo. I looked it up while you were there because I'm going. I'm probably wrong.
Okay. So what is?
It's circumsolar. They're circumsolar.
Okay.
And
we're all in a circumsolar.
So they have their own independent. Each one had their own independent orbit around the sun. That's all.
Okay. Yeah, I wasn't sure. I'd never heard anything about L2 spacecraft. You know, a cool thing to do is to get NASA's Eyes on the Solar System app. You can do it on the web too. Just go eyes.nasa.gov, and you'll show you where the stereo spacecraft are right now. It's really cool. Yeah, you're right, Hans. The leader of a cult thinks he's building a community, but it's not really. Here's how you tell if you're in a cult versus a community. A community is everybody contributing according to their strengths and abilities. And if the leader is gone, the community doesn't die, right? The community stays alive. And you've seen plenty of cults or YouTube channels, as I like to call them, where if the guy doesn't make videos, the community isn't there, right? So that's how you know if you're in a cult. I think that's one of the ways I decide anyway, if you're in a cult or not. And I don't want that. It's like I don't want to be in a cult where if I post a video, you know, I get all this attention, and then if I don't post, then the community just goes away. What if we all got together and just talked about space in all kinds of different venues? That's why I'll stream everywhere. I don't stream just on YouTube. And that's why I have this Discord server, which I love because I'm always on it. And that's where the heart of the community is, in my opinion, is on Discord. So you're always going to get that. So Stephen Porter, I've got a Celestron. What's the best lenses to buy for looking at nebulae, as it only came with 2? You probably got a couple of Plossels. This is not on JWST, so this is going to be a digression. You probably got a couple of Plossels, maybe a 26 millimeter, maybe a 40 millimeter. I don't know what you got, but to be honest with you, those are good enough for looking at nebulae. You want something around 100 power, whatever gives you 100 power. Plossels are really good. The 1 1/4 Plossels are just fine. You don't, with a scope like that, you don't need to spend thousands of dollars on an eyepiece and get good views of the nebulae with it. So, you know, I would, what came with it is probably among the best. If you're not happy with the images you're getting, it's probably due to a number of factors, notably where you're observing, probably a lot of light pollution, probably don't have a lot of filter ability, you know, dark sky filters or whatever it is installed. You might want to look into getting one of those instead of a new eyepiece. And you've also, you know, what is that, 102 millimeters? That's, you know, pretty small scope for getting a lot of light collection. So you might want to look at maybe something bigger aperture wise. So if you're not happy with what you're getting, or go to a dark sky. Good test is, you know, can you see color? Can you see the trapezium in Orion? That's a pretty good telescope if you can, especially from your backyard. You know, if you can find the Crab Nebula at all, you'll probably pass it 100 times before you realize you've looked at it. That's a good scope. If you can see the Crab Nebula with your eyes through a telescope, you got it made. That's faint. That's very dim, very hard to see. It's coming up. It's coming up now in this time of year, late in the evening, in Taurus. So, that's my deciding factor on whether to think something is good observational. If I can see the Crab Nebula with it, I'm pretty happy with it. That's how I look at it. Okay, Uncle Bill, regarding rescue repair, yeah, let's cancel even more science to sink more billions into the same sunk cost fallacy. I know. Yes, we are definitely in a sunk cost fallacy here with James Webb Space Telescope. So, wow, we have spent so much money in this thing. We can't give up now, right? We're like gamblers. Like, I've lost all my money. I've just one more time. I've got to get it back with just one more. So, yeah, at some point, you got to cut your losses. And that's what Congress was trying to say in 2018. It damn near did. Eduardo, are you trying to build a foundation? That's right. Foundation is coming out on Apple. I don't know what I think about that. The television series Foundation. I am no psychohistorian. So Harry Sheldon, I am not. But no. Anthroparian. Anyone measured a SpaceX Starship for it if it could fit Hubble in it and bring it home for a well-deserved stay in the Smithsonian? That would be a good use of that. I would support that. Well, okay, Uncle Bill, I'll forgive you this time. But yeah, it'd be great to jump on in. Let's see. John's got a lot to say about this eyepiece business. Don't buy a Zoom eyepiece unless you pay lots of money. They're crap. There's plenty of good eyepieces out there. Buying Astronomy mag and looking at the adverts. Yes, that's true. And you don't got to spend thousands of dollars. You can, but you don't have to on an eyepiece. In response to Uncle Bill, Anthroparian is like, if the U.S. Congress decides they don't want to fund future space telescopes, they should really look to get the most from JWST. Of course, I'm assuming the electrics and camera will last. They are going to go forth with W first, which is just announced. In fact, I don't know if this will be my first space fan news or not, but I'm going to talk about the cost overruns and delays for W first. Oh yeah, Barlow's a good. I'm having two conversations here. Barlow's can be good way to increase magnification, but they won't necessarily work very well on nebulae, in my opinion. JWST has a limited lifespan due to coolant, I believe, unless it could be replenished somehow. It's not coolant; it's the fuel thrusters. Remember, like I said, it has to maintain that orbit, and that orbit requires firing thrusters, and that will be the limiting thing. They're hoping to get 10 years out of this, but once it's gone, it's gone. It's got to be. There's no gas station up there to refill it, and that is another single point of failure. Once that hydrazine and whatever it is they're using, I think it's hydrazine. Once it's gone, there is no controlling Space Telescope any longer at L2, and it'll probably end up getting unstable and going somewhere else. And that's why it will never last as long as the Hubble Space Telescope. I'm convinced it's from William on Facebook. Oh, wow. I'm convinced that everything will be fine and that we'll be able to unearth a piece of God that he leaves to be discovered. That's a good sentiment. Good eyepieces. This is from James again. Will work for every telescope you buy and last you a lifetime. That kit in a briefcase are not very good from Celestron. Very cheap. Okay. Well, I'm not going to comment on what it'll work. I wish they had built two simultaneously, just in case one failed. Shahid is saying, yes, I agree. But we're lucky to get one out of this. Just saying, Hubble should never have launched with that defect. Well, it's amazing they didn't even know it until it got up into orbit, isn't it? I mean, spherical aberration is like I said, that's a telescope 101 error. So we designed end in the 90s. No refueling considerations could have been taken into account. The 30-meter telescope is still being built. Yes, but it is still a ground-based telescope. And as I pointed out in last week's stream, remember that graph of the atmosphere I showed you? No care how big a telescope you build, the atmosphere is opaque at the wavelength range that JWST is going to look at. So I don't care how big a telescope you build on the ground, you're not going to see these wavelengths. And they're important because the distant universe, the very first earliest galaxies, stars, all that stuff, the only way you're going to see them is by looking in the infrared. And because the universe is expanding and redshift and all that, that's where the photons are by the time they reach our detectors. They're in the infrared portion of the spectrum, and we cannot see that from the ground. So you're SOL, to use a scientific term. Let's see. I'm going to leave you guys to talk about the telescope thing. Euclid launches late next year on Ariane 6, first scientific launch. Yes. And Uncle Bill, I'm thinking that infrared capability will be useful to study stars near Sagittarius A star. Let's see some squeezars. Oh, dude, did you have to bring that up? Oh, Hans Milling, landing is hard, but docking with the spacecraft is far more easy if you know your orbital mechanics. And Dr. Lungworm, Elon Musk walking on water. That's a cult I want to join. A lot of people are in that cult, right? They're in that Elon Musk SpaceX cult, man. They love them some Elon Musk. If he passes, boy, it's gonna be like if he ever leaves this earth, which of course he never will because he's immortal. There will be some sad mofos around here. Hans Milling. All the volcano activities around the world would cause problems for Earth observations, right? With all the pollution in the atmosphere. Yeah. Is it Kilauea? What just went on? Kilauea just erupted today on Hawaii. In addition to the one in the Canary Islands. Jammin, which is more powerful, radio on the backside of the moon combined with Earth radio or optical at 500 odd AU using sun as a lens? 500 AU. That's way out there. Optical. The problem, I think, is less about where you are as what wavelengths are visible to you, right? On the moon and at L2 point, which are very comparable locations, you can see more or less the same thing at all wavelengths because it's in space and the moon has no atmosphere to filter out things like UV or IR or any of the other wavelengths. So it's more about the wavelength range being in space than it is about where you are. I don't know that you get much being 500 AU out. And in fact, you get a lot of things you don't want. Like one of the great things about being at L2, 1.5 million miles away, is that, I think the signal travel time is like 8 seconds or something like that. It's on order of just a few seconds to communicate back and forth to the telescope. It's not as fast as Hubble because Hubble's right over the Earth, but it is away from the Earth at L2 enough that it's looking outside the solar system from that vantage point, not toward the sun. So no matter where it goes around the sun, it's always looking away from the sun out into space. That's a pretty good spot to be. The moon, the far side of the moon, same thing, except for when it's pointed to the sun. It'll have periods where you can't see anything but the sun. So that's not as ideal. I'm told it's a great spot for a radio telescope. I don't know much about radio telescopes. But again, I think the reason it's a good spot is you can build large arrays, huge receivers up on the moon that are more problematic here on Earth. And of course, radio noise on Earth is a real problem. So putting it on the far side of the moon, the part of the moon that never faces Earth, you get a lot of shielding from all that radio noise. That's why they want to put it there. However, it's also a good spot for other wavelengths, as long as it's not facing the sun. In those periods, you really can't do much of anything but observe the sun. So you'll have to wait until the moon is in an position in its orbit that it's facing around, away from the sun. As we all know, the moon goes around about once every 27 days, and so we don't have to wait that long. But I think the reason everybody's excited about radio happens to be that's a good spot to shield it from all the noise, the radio noise here on Earth.
I just want to ask something.
Oh,
How
go
are
for
they
it.
gonna protect it from meteorites on the far side of the moon?
Oh, I don't know. But yeah, it'll be a problem, wouldn't it? I think the advantage of putting something on the moon means that you can repair it right? Imagine something like Arecibo sitting in a crater on the moon, right? It's a big, big dish that's mounted built in a crater. It's going to get hit by stuff. I don't think you can really prevent that from happening. But, this will be a man thing, right? This will be something we could go to, we could walk around, and we can go fix it. So I don't think you can protect it as much as fix what does happen.
I imagine they would have early warning radar or something.
Yeah,
by
we're
then.
talking micrometeorites, right? I mean, we're talking
Mhm.
real tiny things. I don't think we can track that kind of stuff.
All right.
Yeah, but it's a good point. I mean, it's not no atmosphere comes with its set of downsides too, right? On the one hand, you can see all these wavelengths. On the other side, you don't get any protection from infalling meteorites or micrometeorites, especially. So, it's a good point though. Looked at Andromeda and it looked fuzzy. Stephen commenting, well, that's it looks fuzzy to everybody, even in a 20. I have a 20-inch Skywatcher, and it's fuzzy in that too. All right, so you guys are talking about that. I'm just reading comments here. NASA should partner from Dan. NASA should partner with a lot more countries to share the cost more equally. The U.S. doesn't need to do it alone as costs rise. Well, they do. I mean, this, ESA and the Canadian Space Agency don't have minor roles here. This is a big. They're contributing a lot. 300 million euro is a lot. So I agree, it's not billions, but they're not stupid like we are. 8 billion should be spent on carbon capture, not this. But either way, I'm all for astronomy. Look, Mickey. Mickey is loud. It's not like this is either or. Okay, if we don't spend $8 billion on JWST, then we can spend $8 billion on carbon capture. Right? No way. First, we've got to agree that there is a problem with carbon on the Earth at all. That's like step 0. We're not even there yet, right? But if we could get there, then maybe a step would be, well, is one of the solutions to the climate change problem capturing carbon? Then you got to get the whole world to agree to that, and then maybe you could spend some money on it. We're still at step 0, right? I mean, I am astonished that here we are, how many years into the Paris Climate Accord, and not a single country has put forth a plan of how they're going to meet their own commitments. So this problem is not even close to being acknowledged, much less solved. And so good luck with that. But you've fallen into something that a lot of astronomers fell into as well. What we used to say at these meetings when these astronomers would come up and they would say, well, I hope you're happy you're getting all the money for JWST and we're not getting anything. That's not how it works. It's not as if you didn't spend the $8 billion, $10 billion on JWST, then suddenly that money is available for other things. That's not how this works. You've got to raise that money. It has to be allocated and made available to missions down the road that are approved and have something. And so it's not as if you got, oh, well, we're not doing this, but we do have this $8 billion that we could spend on other stuff. NASA's budget doesn't work that way. So, and you have to remind people of that at these meetings. You have to say, well, it's not as if you're going to have the money if we don't build it. You've still got to make a case for everything you want built. It is true, however, that it did put a strain on NASA to be able to do other things. But let's look around. Perseverance still landed on Mars. InSight still landed on Mars. Dragonfly is still going to Titan. So, and Europa Clipper is still on its way, or still going to go to Europa. So things are still happening, but it's not as if we didn't spend
$8 billion was spent on JWST, and that sunk cost.
Yes.
Right?
Yes, you don't get it back. Just because NASA has said this is what this costs, you don't then get that for other projects. Are we saying the same thing?
Yep,
Okay.
exactly the same
I'm
thing.
not sure if we're arguing or what.
No, I'm just saying what I think about it, right? I mean, that's what you want me to do, right?
Yeah.
As
Optimistic.
as
We
part
gotta
of
be.
your community, right?
That's right. We are an optimist. Are we an optimistic community? Personally, I've been accused of not being optimistic. Um, so maybe that's not a
No,
requirement for our community. Maybe we should be realistic. How about that?
yeah,
Let's have a realistic community where
I
we
refuse
say
to be a
what we.
pessimist or a cynic. I, you know, because you can say
Well,
this is
that's
bad,
limiting.
but there's realism, right? Like JWST could fail,
Yes.
right?
Yes.
Is that going to be the end of the world? No, it's not going to be the end of the world.
No.
I would
Might
be
be the end of
ecstatic
NASA.
if it works,
It might be the end of NASA, but it
right?
won't be the end of the world. Right.
Yeah.
Yes, the world will still turn. The sun will still rise and set. That all of that will happen. The trees will the trees will grow. The birds will sing. But yes, but I do think that it would be catastrophic for NASA should this thing not go. Okay, so Anthroparian. I was not born when they stopped shooting Saturn V in the sky. I have always wanted to experience a rocket launch of that power. So Starship is exciting for that. Yes, and so is Falcon Heavy, and so is SLS. SLS is probably bigger than Starship, I think, but admittedly, it doesn't launch anywhere near as much. So yes, people. Here's what I don't care. I love Starship. I love SpaceX. I love Elon Musk. I love what they're doing. I think it's good. But let's be real here that this is, just a guy running a company who has his own agenda, and that there are going to be um, conflicts between what he wants and the public interest, right? So we don't have to just like slavishly, love every single thing he does. I mean, the guy's a bit of a tool, really, but he's also doing a lot of good things. Let's just acknowledge that. I'm not going to sit around and worship the guy, but he does do a lot of cool stuff. I mean, I have to admit that freaking Tesla. I was at that launch where he launched that Tesla with the first Falcon Heavy, and that was pretty cool. I gotta admit, yeah, it increased the space junk by a lot, but it didn't get anywhere near Earth. It went around Mars, and I mean, come on, man, that astronaut sitting there looking like a heavy metal scene from the Heavy Metal movie, which is you guys are too young to know. Um, that was pretty cool. I mean, he knows what's cool. He's definitely one of the cool kids. Okay. Oh, I see. So Tolu is like he wants to use sun's gravitational field as a lens. That's why 500 AU. I see. Okay. So okay, that's what you get. I get it now. Okay. So the advantage to putting a telescope 500 AU away is that you get the gravitational lensing assist from the sun. So, okay. But everything else, wavelength range, all of that kind of stuff is still the same no matter where you are up in space. Let's see. Anthroparian, they are spending billions on fusion power research. They are spending sufficient billions on new power sources too. It's not like there's not billions going into the climate. Well, yeah, I don't know about that. So let's see, Fawad. I think the point is people in USA see China spending silly amounts and getting a bit irritated that why can't USA do it too? Yeah, cheap labor, among other things. Right. Well, I mean, yes. China is doing a lot, but they're also doing a lot that we don't know. But who knows? They may be the next big thing. They may be the next leader in space. So God has joined us and said that JWST is probably the best money spent if it's successful. Well, God, is it going to be? You live outside of time, so tell us. Dude, I wish I knew. Jammers wants to know when's ELF going to be operational? The Exo Life Finder telescope. I don't know, man. If it's even going to get built. I've been meaning to. I need to reach out after my last stream and see if Jeff Kuhn and those guys have any news. I watched your channel back in 2012 as a kid, and I remember you talking about JWST and getting me excited. 9 years later, I am starting a master's in astrophysics, and I'm still waiting. Well, welcome, Costa, and congratulations on getting on going into astronomy. You're going to love it. I'm very excited for all the things that you're going to be able to do. The JWST is your telescope, right? So you are just starting out. You're getting your master's. Presumably, you'll go on to get a PhD in astronomy. JWST is made for you and your generation of astronomers. And that is something I'm very excited for you for. There have been careers that have come and gone over the time JWST has been built. So now it's finally getting launched. The young astronomers just getting their PhDs and working as postdocs and working in various programs around the world. This is going to be their telescope. And the amount of discoveries and observations that are going to come out of this thing will be amazing. And I'm very excited for all the young astronomers out there. So congratulations. And thanks for watching my channel back in 2012. You know, 2010, I think, is when SFN was born, if I'm not mistaken. But 2012, yeah. So thanks for being around. That's a long time. That's a long time. So Shahid is commenting, a failed Webb will be demoralizing for mankind. It'll take a long time to get over it. It will be. It'll be a real gut punch, man. If it doesn't make it, we're going to all be like, ugh. I don't think
Oh, dear.
I don't get out of bed. Brandon watched heavy metal when he was 6. I'll never forget it. Question for you. Did you like heavy metal or heavy metal 2000 better? I liked heavy metal, the first one, better. Heavy metal 2000 sucked. Hans Milling. SpaceX only created Starlink to fund their rockets. If they can just get 3% of the world's internet connections, they will earn billions of dollars. I've said this before. I'm mixed on this whole Starlink thing. I've actually signed up. I paid my $100. I'm waiting for my kit. I'm waiting for it to come available in my area, get out of beta. But at the same time, I don't really want 42,000 or whatever, 14,000, whatever they're launching up into space. I'm not sure I'm keen on that. But I want some choice with my internet connection. So I applaud SpaceX for that. Uncle Bill's commenting, line item control over NASA budget means politics controls every little piece. Politicians tell scientists, engineers, get us from A to Z, but you can't have J, K, or L. That's true. In fact, it's really dictating what's going on with the Artemis program. They were told by Congress that you must use the SLS to get us to the moon. And NASA is like, well, the SLS isn't ready. And you want to get to the moon by 2024? That's what Trump said. And, you know, the SLS isn't even able to fire right now. They keep having these different problems with it. And we can use SpaceX to get there. It's already working. So we can use it and go there. And so Congress, as you point out, who controls every little dollar that NASA spends, has said, okay, well, you have to use SLS unless it won't be available. And that finally freed NASA. This happened just a couple of months ago. It finally freed NASA to be able to look at private contractors who are using reusable rockets to get them to the moon, to maybe get things to the moon. Of course, Starship is top on that. So you're right about the constraints, and that's another reason why, just because you don't spend $9 billion on JWST, that you have money to spend elsewhere, because this is one reason why. So astronomers go, oh my gosh, you know, I would love to be able to spend this money on something else. Well, you can't. It's only for JWST, and if it's not going to spend on JWST, it's not available to NASA at all for something else. So, ELF and Star Shades, all of that stuff's coming, man. It's all coming, but it's going to be way after. We're talking 2030s, okay, before this stuff happens. ELF, I don't know when. Star Shades, Louvoir, all that, 2030s, okay? So you remember the history of JWST. We started with 1989, and now here we are finally getting ready in 2021. So we're going to have a dearth of science if JWST doesn't launch, just because it's going to take a long time to get anything more up there. That. Anthroparian, I agree. Jeff Koons a good guy. I consider him a friend. He does deserve the funding for EXO. I think it'll work, and he's right. I think that it's worth funding. Well, we talked about this already, Richard. Why not build more than one telescope? we're lucky to get this one, right? Remember, shit had to be invented for JWST to be built at all. And that's part of the reason for
Yeah.
the $8 billion price tag, or $10 billion now. So you don't just build 2 of those if you don't know it's not going to work, right? It took a lot of design reviews to get through to that point, and by then a lot of money had been spent, and so you can't justify doing backups of something that isn't space tested. And this is basically a Pathfinder mission and the main mission all rolled into one, if you think about it.
That seems kind of ridiculous, though, to me. It really does. I mean,
I don't see how else you do it.
It's well, okay. The thing is that you have the design there already, and I mean, it's the research that you had to do to get the design in the first place that took a lot of that money, right? The manufacturing sure is going to be costly, but not nearly as much as the development, right? I mean,
so you're saying go through the development, the design stage, and after you've passed that review and you've proven that this equipment works and that it can be built and it can do that milestone was reached at JWST in 2007. So it was after all that other work, decades of work, or the decade or so of work prior, led them up to say, yes, JWST can do what we want it to do. At that point, you're saying go ahead and branch off and build 2.
Bill,
is that right?
Let's put it this way: the sunshade isn't going to be one part could fail in this, right? Whether it's the arms not deploying properly, or the sunshade not deploying properly, or whatever it is. Okay, that is the only component that you would have to rebuild. Okay, or at least, I mean, okay, there are more than one thing that can go wrong. If nothing else, you can have a mock-up that goes in the Smithsonian, right? If everything goes right. You know what I'm saying, right?
No. Are you talking about building a non-working model? That doesn't help you. I mean, you're talking about building. I thought you were talking about building backups.
To me, to put everything in one basket like this is something that
I know.
As a network administrator, I'm just going, my skin crawls.
I know, man. It's like, what? Are you kidding me? I get it. I mean, that's why it's such a ballsy move, man. That's why when NASA decided to do it this way, you gotta hand it to him, man. That took some cojones.
Oh yeah, when you said, yeah, we're gonna bolt a set of balls on this thing. Yes, of course. This is just so ballsy.
They should hang at the momentum.
It's
flap,
incredible.
Right? That'd be so fucking funny. I mean, so there's this momentum flap on the underside of the sun shield that compensates for the solar wind. They should hang them there. And there should be hexagon.
Somebody has to
2 hexagon shaped balls
to animate that.
A couple of D12s or whatever. Yeah, is it D12s? No, it's D20s. I forget which one. The dice which has the hexagon shape. Anyway, get a couple of those. That'd be awesome. I should make those and sell them to the community. That should be a community thing.
Yes.
A couple of JWST balls.
Yeah, there you go.
That's what we should make, man. I can see it now. They're gold.
I mean, from my perspective, that it's all going to this one thing is just so counterintuitive from the way that I look at it, right? It's like where there's goes and no goes, and I guess the thing is that at some point you have to try it, right? And I know that they've unfolded it and all the rest of it independently on Earth.
And it's important. Let me just point out why you're saying that they didn't just unfold it here on Earth. They went through a lot of trouble to simulate. They hung this thing from rafters or something in such a way that Earth's gravity wasn't part of it, right? So they unfurled this thing in an environment as close to space as they could get without being in space. So the testing, that's why the testing and integration part of this mission was such it was responsible for most of the delays, right? They built this thing relatively quickly, but it was the testing and integration that took so long because they needed to test all of these parts in an environment that they were going to be operating in. They brought the cryogenic chamber that was used during Apollo out of mothballs at Johnson Space Flight Center so they could test all the entire spacecraft in a space environment. It didn't have the sunshield part, but it did have the temperatures and the vacuum and everything necessary to make sure all of the thing worked as a unit. And then when it went to Redondo Beach, they had this big giant clean room where they would suspend the entire spacecraft in such a way that Earth's gravity wasn't affected. I don't know how they did it, but so when they did unfold it, it was as if it were being unfolded in space. So I don't know what else you can do. Short of doing what you suggest with these Pathfinder missions, let's just launch up a small thing with the sun shield and let's see if we can, unfold it. Then you got the optical tube assembly that you can't make a Pathfinder for. The optical tube assembly is huge. It's got all of those hexagonal segments on it. They have to unfold properly, and then the secondary mirror tower has to come down. All those hinges and everything else have to work just right. And you really they did that in the cryo chamber at Johnson.
Yeah.
But that's about all you can do. So I don't know. They did. I don't know. I don't see how you do maybe gain something from a Pathfinder type mission on some of the components, but overall, at some point, you just got to test the whole thing, and how it works. One thing by itself in space is nowhere near an indicator of how it's going to work connected all together. So I don't know. Well,
Yeah.
but it is ballsy, man. This is all or nothing. This is all in.
Yeah. Toe curling. It just
Yeah, I call it
just
sphincter tightening.
absolutely.
Sphincter tightening.
Yeah. Yeah. Yeah.
WR is commenting, I don't see why we're wasting time on telescopes when we could be colonizing Mars. Yeah, let's do this thing. Well, SLS is in the VAB now, so the first Artemis mission in early next year, so they say. I hope you're right. I'm going to be watching it. That is an impressive rocket to see go off, even if it is a waste. You throw the whole thing away. It's an impressive rocket to see go up. It's bigger than Saturn V. So,
Tony,
yeah, go ahead.
I hate monopolizing this because I know that
You're
you
the only
want
one
more
talking,
people to
so,
talk. Okay,
yeah, nobody else is.
But I'm just giving an example. Okay, this is the way I see with progress. Okay, right now, I live in St. Albert, which is just outside of Edmonton, and I have an energy efficient furnace that burns natural gas. Okay, and as far as heating my home, it is so miles more efficient, okay, than the furnace that my father had or that his grandfather had. And I think you can go to a lot of things that efficiencies have progressed and we no longer use electric light bulbs, and there are electric cars coming down the pike, and it's all about energy. But one of the things that we've done is that we no longer burn coal to make steam because there is a more efficient way of doing this. And I know that climate change is real, and I know that there's research into producing energy, and the real culprit is CO2 or carbon, right? And that's when we're in denial of that, and we still need to maintain energy, the current demand for energy, and transition to electricity, because that's really what we're talking about. The one part of the conversation that usually is ignored is that nuclear one. and it scares the hell out of us, right?
I've
But
long been
we're
a
going
proponent
to
of
find,
nuclear power. You talking about for energy generation?
yeah,
Yeah. That's a separate
yeah,
topic,
yeah.
but yeah, I mean,
Yeah.
I was I like
I mean,
nuclear power when it wasn't.
it's not great. I don't love it, right? But
I don't
it's
see how you get to fusion
our best
without it.
alternative.
You need the technology and the
Yeah,
techniques that fission gets you to get to controlled fusion reactions. It's not a direct correlation, direct evolution, but you need experience with nuclear fission to get to nuclear fusion. It's a different problem. I understand that the reactor design are completely different, but
yeah,
you still need experience controlling large amounts of energy like that. And so I think one of the ways you get there, it's like going to, that's why I'm a proponent of the gateway around the moon. You get to the moon better if you've got a platform right above the moon, an infrastructure in place. You get experience being outside of the magnetic field of the Earth in order to get to the moon. So I've been a proponent of fission in that way because I think that is part of the path forward for fusion. But you know your points about efficiency are well taken, but it doesn't really have a lot to say about JWST except for materials, right? The things that we built JWST out of, the beryllium for the mirrors, the
yeah.
stuff that was used to build the spacecraft superstructure, all that stuff that did not exist in the 60s, and orders of magnitude. It's possible now because of the materials that we currently have available. It would have been impossible to build this telescope 20 years ago with the
Yeah.
materials they had.
And
It
30
took
years from
it took
now,
the
who
design
knows what
review.
we can do, right?
That's right. It took the design review in 2007 to finally say, okay, we can build this thing and it can do what we want it to do. That's a long time to do that.
Yeah.
So Architufus is like, I hope that the military have a space JWST stored somewhere. He is alluding to WFIRST, which is basically a spare Hubble chassis that was sitting around in the archives of the
Vera Rubin?
National Reconnaissance Office. Why in the hell? They had two, by the way. And they say, hey, suddenly, all of a sudden, the National Reconnaissance Office says to NASA, hey, we've got two Hubble chassis. Would you like them? And besides asking the question, what the hell are they doing with two Hubble chassis? NASA said, yeah, man, we'll take it. And WFIRST and the Nancy Grace Roman telescope became possible because of that. It was a scrap program until they announced, oh, look what we found, which begs the question, what are they doing? That's their spares. That's the spare ones they had laying around. What are they doing with the ones they used? Okay. So yes, maybe they've got a spare JWST laying around that we could use if this one blows up. Okay, Architufus is commenting. He's saying, bail to back up. If the first one fails, you can launch the next one. If the first one succeeds, you can donate the backup to a museum. Oh, okay. Is that what you were saying?
Yep.
Yeah. Okay. Sorry. Okay. Did you have something else you wanted to say? Because I'm getting ready to close out the stream. I've been at this for 2 hours. I can't believe you guys. Is anybody? Yeah, people are still watching. That's amazing. Okay. Somebody was asking if I'm going to do a stream. I can't find the thing anymore. Somebody somewhere asked me if I was going to do a stream for the launch. Absolutely. I'm doing a countdown to JWST video series. They aren't live. I'll be posting those leading up on December 18th. Let's get together as a community and let's watch this thing go together. Yes. So to answer your question, I will be doing something on that day. Most definitely.
Yay!
So we'll all get together and watch this thing not blow up. So I can't find that anymore, but yeah. Jiri was saying, thank you for mentioning nuclear power. It is such an unconsidered resource. Yes, I have a lot to say on that, but a lot of it's controversial and I don't have time anyways. Let's see. Greg Lawrence commenting, if the F-35 fighter jets are too big to fail, then obviously the JWST is even too bigger to fail. That's right. There's nothing on TV. That's why we're still watching you. Okay, John. Thank you very much. All right. With that, I think we are. Oh, James commenting. What 2 hours seems like 10 minutes. Thank you very much, James. But to be fair, you got here late. So all right. Thank you guys. I'm going to end the stream here. I will be back on Tuesday for Tony's Twitch Tuesday. I won't be streaming on YouTube. I only do that on Thursday because I'm anti algorithm. I like to irritate the algorithm. Yes, I'm supposed to be consistent. Yes, I'm supposed to be pandering. Yes, I'm supposed to tell you to do all this stuff, but I don't feel like it. I don't feel like streaming on YouTube on Tuesday. So I'm not gonna. I'm gonna be on Tuesday on Twitch and Twitter, and they have better alliteration on Tuesdays than YouTube does. So Tony's Twitch, Twitter,
And Discord?
Oh, and Discord, always on Discord. So if that's I connect to that first, and then I go everywhere else after that. So definitely join me on Discord. The link is in the description box, all of that stuff. And I will see you next week. I don't know what I'm going to talk about on Tuesday, but in 2 weeks on Thursday, I already know I want to talk about lunar telescopes. I'm doing 2 weeks because I have to prepare for this stuff, and it takes me a while, and I'm not going to get to it for that. And so if I have to think a lot about what I'm going to say, I need more preparation time. I don't know what I'm going to do next week, though, but I will be back. All right. So on behalf of
Nuclear fission.
Nuclear fission. No, well, it's got to be spacey, I think. I don't think people want to watch me stream about energy sources, although I could talk about solar power too. I set up my own power plant here at home. I have a 10,000 watt solar plant here in my house, complete with battery
Is that
backup.
right?
I do, yeah. So I could talk about that at some point. I did it for hurricanes.
You could also talk about microwaves, beaming that, and why that didn't work, or how it didn't work. They were experimenting with beaming microwaves to transmit power back in the 60s.
Oh,
did you know about that?
I didn't know. That sounds
that is a really
that sounds dangerous.
Yeah.
Right.
I think you've got the dangers of microwaves,
okay.
beaming. Yeah, basically.
I don't know anything about that, so I probably shouldn't.
Yeah, a death ray.
Yeah. All right, guys.
Yeah,
right,
well, that was supposed to be the lead in to space-based energy sources.
Yeah, having floating space platforms shooting power down. That always sounded like a bad idea to me. All right, well, I'm going to cut out now. Thank you. Thanks, Tony, for joining. And all the other guys, Homo sapien, Dr. Lungworm, and Nuki. Dr. Lungworm, I should have made you say something, but I didn't. I was nice to you. Anyway, next time I will. Thank you for joining. Thank you all so much for watching. And as always, keep looking up. The best part of waking up is Folgers in your cup. Oh, by the way, which one's pink?